Hello, everyone. For those of you who are joining us for the first time today, welcome and thank you for joining us. I'm Jawairia Ahmad from the Center of Water Informatics and Technology at LUMS. The seminar today is a part of a series of webinars called Conversations with Women in Science and Technology, which aims to bring exemplary female scientists from diverse backgrounds for students to learn from and interact with. It is very important that we identify and share the contributions that have been made by these exemplary female scientists as they serve as role models for early career scientists like myself and for students throughout the world. Today, we are extremely happy to have with us Dr. Miriam Jackson. Dr. Jackson is the program coordinator for the Cryosphere initiative at ICMOD. Originally from Northern England, she did her bachelor's in mathematics and astronomy in London and obtained a master's in geoscience from Ohio State University with fieldwork in Antarctica and Greenland. Her PhD research at Caltech focused on Williams ice stream and the Kamba ice stream in Antarctica. Important to note is that she had 2 children during her PhD. After graduation, she joined the Sverdsand Subglacial Laboratory in Norway and worked on Glacier Lake outburst floods, commonly known as GLOBs. She has also led projects in Bhutan and India, initiated glacier mass balance measurements in Bhutan. While in Norway, she became involved with the IPCC and was a lead author on the High Mountain chapter in the special report on the ocean and cryosphere in a changing climate. In addition to her commendable research contributions, Dr. Jackson also leads private excursions as a glacier expert on Svalbard. Thank you for joining us, Dr. Jackson. There will be a question and answer session at the end. If you have any questions, please feel free to write them in the chat box or send them to me, and the presenter will be happy to answer them at the end. With that, Dr. Jackson, the floor is yours.
Okay. Hello, everybody. Good afternoon. I think most of you it's afternoon, or good morning or good evening. Thank you very much for that very nice introduction, and thank you so much for the invitation to speak here today. It's really nice for me to be asked to speak here. I'm going to be talking about the importance of the cryosphere in high mountain Asia, what the cryosphere is, how it's changing, and what those changes mean for us as well. And I also would just like to start off by saying I'm giving this talk, I think it's about 5 days since International Day for Women and Girls in Science. And it's also 2 days since Valentine's Day. So this is quite appropriate. I'm going to talk about my love for the cryosphere as a woman. And it wasn't very hard, especially when I started to do cryosphere sciences, to do glaciology. And in the brief biography, Jawairia said that I did maths and astronomy, and then suddenly I got to the US and studied geosciences. What happened there? And what happened is basically I wanted to work in Antarctica and study Antarctic glaciers. And as a woman in the UK at the time, that wasn't possible. The only place that you could actually go if you want to work in Antarctica was the British Antarctic Survey, and they didn't take women at all. So the chances for me to do what I wanted to do weren't very good. And I had to actually move to another continent to be able to do that. And I know there's still a lot of challenges for women to be involved in science. And I think that's particularly true for cryosphere sciences, especially when there's also a lot of field work involved. And it's, there's certainly no reason why women can't be doing this. And I really encourage anyone to do it, although you will find a lot of obstacles. So eventually I got to Antarctica and I was there 3 times doing research, both for my master's and PhD, as well as once where I was just collecting meteorites with a different group. And it was amazing experience, but it wasn't very easy to get there. And then I went to Norway and worked there, and eventually I ended up in ICMOD. And ICMOD is an international center. I don't know how many people are familiar with it. It's based in Kathmandu in Nepal, but it's actually working with 8 different countries in the HKH, including Pakistan. So we have a lot of projects in the different countries. Because I'm in the Cryosphere initiative, I tend to have more work in the countries with a lot of cryosphere. And we also have quite a few sort of transboundary projects as well. So obviously geography and glaciers don't recognize international borders, and a lot of things that happen in one area, for example, the Glacier Lake outburst flood, could be situated in one country, the glacier, and then it affects people in another country. So a lot of our work is transboundary. You probably all know the components of the cryosphere. I'll just go through them briefly. So it's glaciers, which is mainly what I've worked on. They get a lot of publicity. They're very media friendly, shall we say. It's very easy to see how they've changed. It's challenging to track them, but in some ways it's quite simple. You can use satellite images from one year to the next, and you can do field work. With snow cover, it's a bit more challenging. Snow cover often tends to disappear from one year to the next, so you really sort of need a lot more steady measurements of it. Permafrost is even more difficult. Permafrost is in many ways invisible. You can only sort of see where there's changes in permafrost, but it's very hard to measure, from satellite imagery, that kind of thing. And then lake and river ice. And at the moment, these are all changing and having effects both on the people living in the mountain areas and also having effects on people downstream. Oops. I was fortunate enough to catch the first talk in this series. It was excellent. It was by Helen Hewitt, who's at the Meteorological Centre in the UK, the Met Office. And she was in the most recent IPCC report and talked about ocean cryosphere and sea level change and gave an excellent talk. And apologies for the really bad figure. This is one of the ones from the latest IPCC report, which isn't actually released publicly yet, so it's hard to get a good quality figure, but it is available to read. And, went through a few of the things that the latest IPCC report has told us, that the ocean and the cryosphere are changing. These changes are widespread and rapid and intensifying, and they're also happening at the same time. When we look at glacier changes in the past, for example, the Little Ice Age, things like that, things weren't quite happening at the same time all over the world, but now we really see that things are pretty much all happening at the same time. We have a lot of glacier melt, unprecedented for at least probably the last 2,000 years. And also we see the glaciers are contributing to sea level rise. In the last few decades, it's about 17 millimeters sea level equivalent. It doesn't sound like much, but that's just in a few decades. If that one keeps on going to the end of this century, this is a huge amount, especially, you talk to people living in Bangladesh, in the Netherlands, in Florida, and low-lying areas are going to be really affected by this. So for the Hindu-Kush Himalaya, the sea level rise isn't really that important, to be honest. It's important for many, many people, but here we're a lot more interested in what's going on in the mountains and just downstream from the mountains. And the Hindu-Kush Himalaya really is a global asset for, for water, obviously, for food and energy, also for biological diversity. This is very important. And the climate is generally monsoon dominated, especially towards the eastern part. So it's a little bit different than people generally, a lot of people studying things like glaciology are very much used to a winter climate and a summer climate. In the winter climate, it's cold. This is when glaciers get snow, but for glaciers in the monsoon climate, it's a little bit different. They could get the accumulation and the melting both in the same season. So the Hindu-Kush Himalaya, it's also the source of 10 major river basins. It's very diverse. It's not even just, several different countries. It's many, many different communities with different languages. There's several global biodiversity hotspots here. So it really is a very important area. And it's also changing very quickly. The temperature is going up globally, but it's actually going up even faster in the mountain areas. So I like this little figure. And this is basically showing the whole population of the world. Each of the little people is represents 100 million people. And the different colors represent, some of the time where those people are living. So the people who live on coastal areas and low-lying coastal zones. And if you look at the white figures, this represents all the people who depend on water from the Hindu-Kush Himalayan glaciers. So they depend on the water for drinking, for agriculture, for energy, and many other things. So put it that way, we're talking about, millions and millions of people. And this is an ice map from the Himalayan Water and Climate Atlas. And it just shows you where those people are. And again, we have another little figure where this time, sorry, the scales keep changing. Here, one person is 10 million people, or the three people together are 100 million. And you see, especially in the Ganges and the Indus, there's a lot of people here who are really, in these different river basins, in the Brahmaputra as well, and dependent on the water that comes from the snowmelt and the glacier melt. And we see a lot of these HKH basins are very highly populated areas. There's many cities here, some very large cities as well. But decisions about what goes on in these areas tends to take place outside of where the actual population is. So it's, one of the things this tries to do is to get the local people more involved in learning what's going on, deciding what to do about it, and just generally cooperating with us as we do our science and how to adapt to these changes. So in the climate context, the climate's warming. It's 0.2 degrees a decade. And it doesn't sound like much, but it's a lot. And as I said, as you get at higher elevation, also in the Arctic as well, by the way, it is actually warming more than the global average. We're also seeing more extremes. So for example, precipitation extremes. We're getting more occasions of intense rainfall, also erratic rainfall. So heavy rainfall when people aren't expecting it. This happened, for example, in Nepal last year, the very beginning of the monsoon was extremely heavy rainfall. And these extremes of temperature and precipitation are going to be more and more common in the future. And these changes in temperature and precipitation, they affect the cryosphere, and this affects the water cycle. I'm sure you've seen this kind of diagram before. Water just keeps going round and round, and it looks quite simple, but if you change how often it does it or how much is locked up in glaciers and how much is in the rivers, it really causes a lot of problems. So you see here just how interconnected everything is, and trying to adapt to this can be a big challenge. This is a figure I like very much. This is from the IPC report called Ashfaq, Special Report on Ocean and Cryosphere in a Changing Climate. And I was involved in this report, so another reason I like this figure a lot. And this is from the High Mountain Areas chapter, and it shows over the whole world where we have glaciers, and that's shown by the blue diamonds. And you can also see from this figure, according to the size of the diamond, the area of the glaciers. And if you look here now, I don't know if you can see my mouse. If you look at High Mountain Asia, you can see there's a very large area covered by glaciers. And then the purple circle at the side, this is the area covered by permafrost. And it's almost as big. And as I said, it's a lot harder to study permafrost. It's certainly very hard to study from satellite imagery. It's very hard to study in the field. You have to go out there and do the measurements. You have to drill boreholes. But the area covered by permafrost is the same as the glaciers. If you look at North Asia, over here, so the Tibetan Plateau, that area, you see the area of permafrost is much bigger. So even though there are very few glaciers there, very little glacier area, the area that's potentially going to be affected by changes in permafrost is huge. And this figure is taken from HIMAP, and there's a couple of things I want to show with this figure. And one is that the glaciers are changing in the HKH. From the color, you can see how fast it's changing. So the redder, the deeper the red, the more the rate of change in percent per year in the last few decades. And these cycles are divided into two halves. So the left half is pre-2000, so up to the year 2000, and the number of glaciers measured in each semicircle. And then after 2000 is on the right-hand side of the circle. So you can see that generally the change is quite similar. In some cases, they melted more before 2000. In some cases, they melted more since. What you might notice is the number on the left-hand side is bigger than the number on the right-hand side. And this is a little bit worrying because, glaciers are changing a lot, as I said. They're very important for people. And yet we seem to have fewer measurements. How on earth is that happening? This is very important. We should be doing more measurements, but we actually have fewer than we did a few decades ago. And this is mainly all glaciers in the Indian Himalaya. And this is a compilation of different measurements. And you can see that it's, there's just not many glaciers. Each of these lines, each of these colors is an individual glacier measurement. Some of them went over several years. Some of them, astonishingly, we have just one measurement. And for glaciers, it changed so much from one year to the next. You can see some of these colored lines are swinging backwards and forwards. And that's quite normal. Some winters or monsoon, you get a lot of snow. Some summers are very warm, you have a lot of melting. So if you want a good measurement of the glacier record, you really need it over several years. And this shows that we just haven't got that. And this is actually from a paper from Farrugh, which is a bit more updated and a little bit more sophisticated. And this is, but it's showing basically the same thing, that first of all, we don't have many glacier measurements. And also where we do have the measurements, if you look at the figure at the top left, we can see generally that it's either negative or very negative. So the glaciers are melting from about 1/2 to 1 meter water equivalent a year. So that means if you imagine how much ice melts from the glacier and you compare that to how much ice and snow and compare that to water, it's about 1 meter water equivalent a year. And that's a lot. So most of the glaciers aren't going to be able to sustain that kind of melting for very long. I'll come back to that later. Nepal is pretty much the same. We have just a few glaciers that are being measured at the moment. Yala is, and also generally they're not continuous records. So Yala's been measured since the 1980s, but it's not continuous, not every year since 1980. Rikasamba, a little bit further west, is the same. And one of these glaciers, for example, AX10 is about, it's just a big ice cube, basically, less than 1 square kilometer. So despite there being hundreds and thousands of glaciers in the region, there's very few measurements. I also showed Chota Shigri, and this is in India, and it's actually the longest record in the area. And I think even there, it's about 20 years continuous measurements. So we do need a lot more glacier measurements in the region. And why are there so few? There's a few different reasons. One is that they're very remote, challenging access. So as mentioned, I used to work in Norway. It was very easy to measure the glaciers. We could hop in a helicopter, or we could just walk or go on our skis. A couple of times I actually did glacier measurements, but I'd leave in the morning and get back home in the evening. That was very nice. Also very different from Antarctica as well. And it's also different from the HKH. Here it's, you know, it's at high elevation. So you, even if the helicopter is available, you need to adjust to the elevation. It takes several days to walk there. And so you have to plan ahead. That means you might end up going there when there's bad weather. So a lot of reason why it's quite challenging getting on the glaciers here. Also, working at high elevation is difficult and dangerous. Some people cope with it very well, some people not at all, and you do need to use the extra time to adjust. Glaciers also tend to sit at the highest points, which is also often where the political boundaries go, and that can also cause problems if you're close to a sensitive border. However, despite there not being very measurements, we do see that the measurements are very consistent. That pretty much all the glaciers in the HKH are shrinking. So I have just a few photos here, because what would be a talk about the cryosphere without showing some nice glacier photos. So this is from Yala Glacier, where the first measurements were in the 1980s, but they haven't been every year since then, although they have been continuous now since 2012 by Isimod. But this glacier also is getting smaller, and it's getting harder and harder to measure, and not really worth measuring anymore. Isimod also established measurements on Piyak Glacier in Afghanistan. And this was also very challenging to do, but now the situation is such that there were no measurements last year. We hope to get measurements done this year, but we'll have to see how things go. So that's also quite challenging. We have measurements on Tana Glacier in Bhutan, and this photo, I think, is from 2013. Yes, we said about the meteorological station there, and this has been measured pretty much every year since then, first supported by NVE in Norway where I was working, and then supported by Isimod, where I'm working now. And now in Bhutan, they're doing the measurements themselves. They go there once or twice a year, and also with support from Isimod as needed. And then we also have some measurements in Pakistan. There's a few different groups working in Pakistan. Isimod started measurements in 2019, but then COVID came. So we're hoping to continue those measurements, but also there's different challenges in getting access. So there's a lot of different things. When we measure the glacier, we measure the glacier mass balance, you know, basically how healthy it is. Is it getting bigger or smaller? And a lot of different things, excuse me, go into what's happening here, the precipitation and the sublimation, so how much of it, the mass is going away. Is the glacier covered in debris? So there's different climatic parameters and also the non-climate parameters. You know, I just have to move because I can't actually see my screen very well at the moment. So there's different things affecting it. And then there's also, it has different effects of the climate parameters that affect the dynamics. And this is one area where we don't know much about glaciers. There's actually a really nice paper just been published looking at glacier surface dynamics on a global basis and actually found that because before we were just looking at it very simply and weren't considering how the glacier transports mass from one part to the other, there's quite a lot that we didn't know. Some assumptions on glacier volume, for example, were quite wrong in some areas. And also changes in the glacier mass volumes have a lot of effects on water storage, water supply, and also further downstream on global sea level. This is quite a complicated diagram, but it's also from the IPCC report, and it shows the different mountain areas and also the polar regions, and looks at what's going to happen in the next few decades. So this is based on what we know about how the climate is changing. And one thing that you can see is that all the graphs go from 0 to 1% on the left-hand axis, and they're all getting smaller. You know, there's no regions in the world where we can say climate projections, so the glaciers are going to be stable here, or they're going to grow. Some of them are getting smaller very quickly. For example, Central Europe here, you can see it's disappearing quite quickly in the Caucasus. And then high mountain Asia, actually not quite as quickly as some areas, but even so in, you know, by the end of the decade, even with a very low emission scenario, the glaciers are going to be a lot smaller than they are today. And what does that mean then is what happens to the water downstream as the glaciers shrink, and how does it affect people? So we have something called peak water. And this means that as the glacier melts, you get more and more runoff. Obviously, you can't keep on doing that. At some point, the glacier is going to disappear, and then you'll have no runoff from the glacier. So as the glacier melts and gets smaller, the runoff gets more and more. And then it gets to a certain point, the glacier can't sustain that. And we call that point peak water. And after that, we'll have less and less water. We'll still have rain in the basin. We still have snow melt, probably groundwater, other things. But the glacier was like a big savings bank. And for example, especially when it was hot and sunny, you had the runoff from the glacier was very good for irrigation. Once the glacier is not there anymore, then that's really going to affect the discharge. And the changes are going to be, you know, depending on what time scale you're looking at. On a daily time scale, as the glacier melts, the discharge increases, the runoff is actually very big. And this could also be a problem. You know, people are sort of used to running their lives around the irrigation being the same, the hydropower being the same. When you suddenly have very large daily variations, that might be a problem. You might not be able to use all that extra water. But on the decadal time scale, you know, you do get this gradual decrease once you get past peak water. And it's possible to see, you know, try and project when this will happen in the different regions according to the different emission scenarios. And what we see actually is many regions around the world, looks like not the ones I'm showing here though, but other regions, we've already passed peak water. So in some areas, you know, the Alps, the Caucasus, they've gone past it and they're now getting less and less water from the glaciers. In other regions, in high mountain Asia, for example, we can see that we're very close. So in the next 1 or 2 decades, we're going to hit peak water. So these changes are, you know, it's not something we have to start adapting to. We should already be well on the way because the changes are here, they're happening now. Oh, there we go. So that was when the report came out, and yeah, you can see how close we are to peak water for the different regions. Another big area of concern in the region, in the HKH, is as the glaciers change, then different things can happen. For example, as they change, if they have a moraine in front of them, then as the glacier gets smaller, you could get a big lake being formed in front of the moraine. In other areas, as the glaciers get smaller, you get the water forming at the side and forming a lake at the side of the glacier and damped by the glacier. If the glacier keeps on getting thinner, that water is just going to disappear under the glacier. For a while, the pressure can hold it back from the ice. But as the ice continues to get thinner, then the water runs under the ice. And a lot of the time, this can happen very suddenly. This is called a GLOF, glacier lake outburst flood. And in the HKH, there's several thousand of these lakes. And there's a few hundred of them have been identified as dangerous just by looking at, you know, what does a moraine look like, for example, and also considering, you know, what happens downstream. If there's nobody downstream, then it's not really a problem. But in many cases, there are people downstream. Often they are a long way away, so they may not even know this is a problem. You know, it could take them several days to get up to the glacier and see there's a big lake forming and it's getting bigger and bigger. So they might not be aware that this is a problem. And this is another, excuse me, I've got a bad throat. This is another graph from HIMA. And this shows also where you have the different glacier lakes. You can see that they're pretty much spread all over the HKH. And the colors also show whether the area is getting more or less. So in some regions, it looks like there are either fewer lakes or they're smaller or both. And this could be because they're gradually running through the moraine or under the glacier. But also in most of the areas, we are getting more and more lakes or bigger and bigger lakes. So this is a problem for most of the HKH. Another important component of the cryosphere is snow, obviously. And this is challenging to measure. We do know a few things. We know the snowfall has decreased in mountainous areas, especially at low elevation. We also know that it's not always uniform. So in most areas it's decreased, in some areas it's increased. It's generally decreased at low elevations, but could have increased at higher elevations. There's also many cases of the snow possibly coming earlier in the season and also having more intense snowfall. So if you suddenly get a big snowstorm in August, for example, then that also causes a lot of problems. And this is, it's getting more unpredictable. People generally live their lives around how things have been for the last few decades or centuries even. And if you're growing crops that need water at a certain time and the water is coming earlier or later, then that's obviously a problem. So although the changes in glacier runoff are affecting agriculture, changes in snowmelt effect are possibly having an even bigger effect, but we know even less about this problem. So we have here again another quite complicated diagram. This is also from the IPC SRAP report. And this shows a few different mountain regions and just looking at the different scenarios where we have the information. In some areas we just have the 8.5 emission scenario. And we can see that in all the regions, there's going to be less snow in the different regions. The temperature is going to increase both in the winter, which is very important for the glaciers and snow, and also the summer temperature is going to change. And what does that mean? Well, people are concerned about this all over the world. For example, in Norway, where I've lived for the past 20 odd years, people are very concerned about the snow season. People like to go skiing, especially in the winter when it's dark and you need to have snow. And this is today's medal table from the Winter Olympics. Norway is top, which will please all the Norwegians. They have a lot of gold medals, so everyone's very happy about that. And this is because Norwegians spend a lot of time skiing. So this is a serious concern about changes in snow cover. Another concern is that the snow melt is used for agriculture. This is slightly more serious than the Winter Olympics. So we have, this figure sounds very exact, but anyway, over 100 million or possibly 129 million farmers in the Indus and Ganges river basins get at least 10% of the water for irrigation from glacier and snow melt. So this is obviously a big problem to them if they're growing certain crops and depending on a certain amount of water coming at the same time. These changes in snow cover are going to be a huge problem. There's different ways of adaptation. If you want to do a lot of work in Hunza, so this is a place called Misgar village, where the farmers have actually been experimenting growing vegetables in tunnels using solar panels. So this is one way of trying to adapt. You can see it does involve having quite a few materials. Also, if you're going to go out and purchase these materials and do this, you really want to know it's going to work. So you do need some kind of support to make these changes when you first realize things are changing and you have to do something if you want to keep on growing crops. And also this area is generally cut off, so it's people want to have local access to crops. You can't just assume they'll be shipped in, trucked in somehow. That you need to be self-sufficient. And if the weather's changing enough that you can't keep on growing the same crops as you used to, then you need to somehow adapt to these changes. I'm sure everyone's seen this picture or a similar one. So this is another way of getting around changes in runoff from glaciers and snow. These, they call them ice stubbles in the DAP, generally very dry area. And this is one way of saving the water. So you had access to the water, when you really needed it for the crops. Because the snow is changing, it also means that avalanches are changing. So avalanches, you get a big mass movement of snow. And generally, if you know that somewhere is exposed to avalanches, then you would avoid that area. You wouldn't build a house there, you wouldn't build a school there. But as things change with the snow cover, then avalanches can occur at different locations. They can also occur at different elevations. And they could also be different types. So there's a couple of different types here. The left one's dry snow avalanche, and then slab avalanche on the right. You can also get a wet snow avalanche, and these are generally a lot more destructive. You can imagine, if you've ever been out in snow, it's nice when it first comes, and then as it melts, it gets really horrible and slushy and horrible to walk through. So if you get hit by a wet snow avalanche, it's going to be very different than a dry snow avalanche. Or if you have buildings and cattle, then it's going to be a lot more of a problem if it's a different kind of avalanche. Also want to say just a little bit about permafrost. So this is something that we know it's widespread in the region, but we just don't know exactly how widespread or exactly where it is. Generally, to study permafrost, you need to have some temperature sensors in the ground. So you need to go there and put the sensors out and get them again. If you want to actually know what's happening at depth, and also have some kind of an idea of the history of the changes, which you can get from boreholes at depth, then that's a much bigger endeavor. Now, I've spent a lot of time doing boreholes in snow and ice, which is quite easy, but doing boreholes in rock, obviously, is much harder. So we just started doing some measurements in Humla. It's a little bit hard because it's even less accessible than most areas, and HKH is not actually connected to the road network in Nepal. And this is somewhere where Isimush hopes to work a lot more in the future, because, as people build roads at high elevations, often they're building them where there's permafrost, and they're going to be unstable. The road is either just going to be thawing in different ways, or it's very prone to landslides if you're building in a permafrost region. And this shows you the whole HKH and where there's where they have permafrost, and this is based on a model, but it shows that potentially it's a huge part of the HKH, and the white dots are boreholes, and you see there's very few white dots. There's 2 transects here, and then a few odd ones. So permafrost is one part of the cryosphere where we have very little information, but we do know that it's changing, and we do know that those changes are going to have a lot of effects, especially for people living in the area. And also there's water locked up in the permafrost. This is also going to change the discharge and affect the water that's available downstream. So these are a few different, sort of a summary of where we are so far. We have the different atmospheric drivers, and these are causing changes in the mountain cryosphere to all of the cryosphere. And generally these things are warming up and getting less. So the glacier area is less, the snow cover is less, the permafrost is thawing, and the area covered by the permafrost is less, but it's also not always a very regular change. And the impacts that we see are very varied. So they're affecting biodiversity. Animals tend to sort of hang around where they think it's comfortable, where the temperature's right, where they can get the vegetation they want. And if the temperature gets a bit warmer, if the water is more or less, then that's going to affect the ecosystems in that area. It affects livelihoods, obviously. It affects water supply and irrigation. Hydropower is a big one. Hydropower, if you start building hydropower, you want to know that water's going to be available for the next 20 years. And also tourism and recreation. This is something that we don't always think about, but it's very important. There's a lot of tourism in mountain areas. If it's not as much snow, if it's not quite as scenic, then perhaps there won't be as much tourism. And also we have the general hazards. So we have floods, we have the gloughs I talked about, and also snow floods. If you have a lot of snow late in the season, and then the temperature warms up quickly, you get a very intense flood from the snow melt. Lahores, which is snow floods, snow melt on volcanoes, and then also landslides, partly because of permafrost, and avalanches. One of the things we've been doing is working with local communities and asking, what do they see as the changes, and also comparing that with scientific data. And generally, they see that the glaciers are melting, the snowfall has changed, the snowfall season isn't as long, it comes later in the season, the intensity varies. So this is very useful that we get a lot of information from our scientific investigations, but also just comparing it with what the locals see, who often have records going back many, many decades. And also they're the ones who are going to be affected. So it's very useful to talk to them about this. And also, doing hazard assessment in Langtang, for example, and how people see these changes and how it affects them. As I said, if you get avalanches in a different area than you did before, you might have a school there or a house or something, or it might be a path that you always use to go somewhere because it's always been safe. So there's several different risks here. This is an attempt to show them, again, from the IPCC report. So the thawing permafrost, the glacial lakes, the avalanches, and also what happens downstream. And this is sort of a before and after kind of thing, that all these different aspects are going to cause problems in the future. And this is doing it in a risk framework. So there's many different hazards, but as I said, for example, for a glacial lake, if there's nobody lives downstream, is it really hazard in the same way? It's still a hazard, but it doesn't affect anyone. So we then also have exposure, who is actually going to be affected by this, and also the vulnerability. Some people are better able to weather these hazards than others. So that's something else to take into consideration. And I think this gives a very good overview of just the different kinds of hazards related to changes in the cryosphere and how it affects people and how well people are able to withstand these hazards. So it depends a lot on things, for example, the social and infrastructure systems. It depends on things, for example, social inequality has something to say. Often gender is involved. This is something we've seen, for example, with investigations near Glacier, that where there's several gloughs have occurred, and it doesn't affect men and women in the same way. This is something else to take into account when finding out what the hazards are in mountain areas and also who's affected by it. And this is also an attempt to consider the cryosphere as, in the same way people talk about ecosystem services, we also have different services from the cryosphere. For example, you have water for irrigation, for hydropower, that kind of thing. It's also a kind of a regulating thing, that water conservation and ecosystem stability regulates it. You have supporting services, for example, biodiversity and conservation, fisheries and migration routes. These are all affected by changes in the cryosphere. And there's also the cultural services. So I've talked a lot about agriculture, about discharge, about hydropower, but also the tourism aspects, and also the cultural and religious or spiritual aspects related to the cryosphere. A few more things that also happen that possibly aren't thought about as much. We get changes in water quality. If you have less water and you have some pollutants, then the water is not going to be as hygienic, as pure to drink. Also, as glaciers melt and retreat, and other changes in the cryosphere, you can also get more legacy pollutants going into the water system. This might also be something similar where if water is bad, then you don't drink it. We might have a water source that's generally been very dependable. But if now, way upstream, you're getting more pollutants into it, then you need to start avoiding that water. And changes in sediment as well. This is caused by, for example, if you have more discharge, if you have glacier lake outburst floods, you get more sediment. And this causes a lot of problems, especially for hydropower, and also changes in temperature. And this is another quite complicated graph. And this is again looking at all the different high mountain areas of the world and just seeing exactly where there's been changes in the cryosphere. And they've had some kind of effect. So here we can see the high mountain Asia region, where the cryosphere is changing, it's getting smaller, where the water availability is changing, where avalanches are increasing. And this is having effects on what we call tundra forest, on the tree systems. And it's also we're seeing that there are already recorded effects on tourism, on agriculture, on migration as well. If people aren't getting the snow melt they need, they might just move to a different area, and also on the cultural services. So these are showed just the documented changes, and you also see something similar in many of the regions of the world. I want to say these are the documented changes, so I'm sure these changes are happening, in all these areas, but if we don't have record of it as scientific document, then it isn't included here. We can see that it's, climate change and its impact in high mountain areas does have effects. It's very related to poverty. If there's weak climate change, then it's going to be easier to adapt to it. We now look like we're heading for 1.5 regardless. If we can stick to that, then it's, going to be easier to adapt to it. If you have strong climate change, if it's bigger, if it's more sudden, more extreme events, it's going to be a lot harder to adapt, and that's going to cause an increase in poverty. So this is a basic summary. Assuming we stick to 1.5, maybe a little bit optimistic, we are going to lose 1/3 of the volume of glaciers by the end of this century. So many of you have children or have grandchildren who are going to see this. Some of you may even see it yourselves. They're going to lose 2/3 under the current emission trend. So if we don't stick to 1.5, if we just keep on going as we are now, we're going to lose 2/3 of the volume. So that's a huge amount. Snow-covered areas will decrease. Snowline elevations will rise. And snowmelt will be earlier in the year and will be stronger with attendant problems and flooding. So thank you. This was a very brief summary of the different elements of the cryosphere and how they're changing, and also how this is affecting the different parts of the HKH. Thank you.
Thank you very much, Dr. Jackson. This was a wonderful summarization of not just what we need to worry about in terms of the changes that are happening in high mountain Asia, but also the different aspects, not just the ice, but the snow, and then how it affects irrigation and agriculture, and not just the communities that are in those mountain communities, but also people like us who are living downstream, how this affects it. Thank you for an amazing overview. So I'll go towards some questions that the audience has asked. And I'll start with when you were talking about measurement of glaciers. So could you perhaps summarize, how do you actually measure the height of glaciers in the field?
So you said measure the height or the health?
The height, meaning we were talking about the mass balance of glaciers. So how do we measure the height of the glaciers, that it's receding or not?
Okay, the easiest way if you want to measure the height is to use satellite instruments. For example, and actually I did have a figure before, but that was because it was quite complicated, but this is one easy way of measuring, pretty much all the glaciers in the HKH, just to see the elevation, for example, from Sentinel. And then we do see that there's, apart from the Karakoram, where there has been some glacier thickening, most of the glaciers have thinned. If you want to do this in the field, you can do it, well, you can do it by laser scanning, where you have a laser from a plane, and also some of the satellites use lasers. Or you can also just, some people have literally used a GPS, a differential GPS, and walk across the glacier, and that way you can also measure it. And it's very important to know, how much the thickness of the glacier is changing. And you don't even need to know the thickness to know this. If you know what the difference in height is, you can see whether, how much thinner it's getting and how fast it's thinning.
So that's a great segue for another question, in that most of the techniques that you mentioned were primarily remote sensing based. How accurate are those remote sensing based measurements in your opinion? And let's talk about Sentinel, and then like a LiDAR or something like that.
They're getting better and better. They are amazing. I said I started off my career in Antarctica, and while I was doing my master's, we got the radar sat measurements of Antarctica, and we could actually sort of see the site where we were working. And this had 1 kilometer resolution. And we're like, wow, 1 kilometer resolution. And for working in Antarctica with the big ice streams, it was useful for that. But for example, glaciers in HKH, it's not much good. But we're now getting down to just a few meters of resolution. So if you want to map glacier area, certainly doing it on the decadal scale, which we're doing at ICIMOD, most of the glaciers are changing enough with just a couple of meters resolution, you can really see how big those changes are from one decade to the next. And you don't, the resolution now is good enough. You probably can also measure it on shorter periods, but you don't really need that much because they do vary quite a bit from one year to the next. There's also a lot of things you have to take into account, but the satellite measurement techniques have got very sophisticated, so that I think the measurements absolutely are trustworthy. People have different techniques and the satellites are different, so sometimes it is hard comparing the different ones. And for some of them, for example, with snow cover, often MODIS is used, which has low resolution. It's just a few hundred meters. But what you want is you want the measurements very often, so that the time resolution is very good. Because when we talk about resolution, normally, especially with glaciers, it's how many meters exact is it? But you also need very good time resolution for other things, like snowmelt. In that case, you use MODIS. So the techniques are really improving. And I think that the results are very dependable. It's also very easy to get, you can sit here and use Sentinel Toolbox yourself quite easily just to measure it, and that's available free, I think.
Thank you for your answer. And I would also point out that it's not just the depth that we're interested in, but also in the area, that if it's the area,
Yes,
it's shrinking. So it is very important that we keep downscaling our remote sensing capabilities so that we can also measure those small glaciers that we have. So I'll go to another question. And the question is that, were the glacial measurements in Afghanistan that you took in Piyak particularly challenging, not just in terms of infrastructure, but culturally, or in terms of communicating and collaborating with the community?
I think mainly it's difficult to start glacier measurements anyway. If I said I worked a long time in Norway, and people had been studying the glaciers there for many decades. Generally went to the same glacier, so it was quite easy. You knew where the crevasses were. If the areas weren't very easy to get to, you knew which paths to use. Sometimes we had to use a ferry. We knew, all this kind of thing, because, we worked in Oslo, but we were working up in the mountains to study the glaciers. We also had the infrastructure there. We had little huts on the glaciers with equipment. If we wanted to study another glacier, we knew exactly what was needed. Starting from scratch is a huge undertaking. What's the best access route onto a glacier? And I did this in Bhutan, and spent over a week, working at 4,000 and 5,000 meters, thinking, okay, there's a glacier there. Can we get to it? How does it look? What's the access look like? So this kind of thing is quite challenging, just starting from scratch. And because of the security situation, it was quite hard for people from Isimod to travel to Afghanistan and say, okay, this is how we generally do things. We had people from Afghanistan in Nepal before, and one or two of them had done a master's here. So that was very useful, but it's certainly a lot easier if you have experience from colleagues who have been doing this for many years to come and help you. If you're just doing it from scratch, it's a lot harder. We did actually put out some instruments to measure the precipitation in a valley that disappeared. This is also a problem which is quite widespread. In Norway as well, we've seen it with equipment. So it's everywhere. And especially when you put something out and, the local people might not know what it's there for, how important it is. Often it's for their benefit, but they might not know this, so equipment can disappear. And then you might have to get better at just knowing where you shouldn't spend any money and put equipment, getting better at hide it. So there was a lot of challenges, but also one of the main ones was just it was starting from scratch with people who didn't have a long experience in doing this. And that's always challenging.
Thank you for your answer. So I have another question here. And the question is that, do you think Gilgit-Baltistan region has a significant amount of permafrost? It's quite a populated region with several cities and valleys and drops. So they're melting frequently. Is melting permafrost also a big problem?
To be honest, I'm not a permafrost expert, so I can't, I could get back to you with an answer on that, but certainly it is very widespread in the HKH, and anytime you get, once you get to about 5,000 meters, generally going to have permafrost. The biggest problems happen when you have people and infrastructure close to permafrost. And I think this has happened in Afghanistan, that there are some roads at high elevations. And, after driving around in Homeland, seeing how some roads are in high mountain areas there, even when things are stable, it's hard. If you then get the ground thawing, then it's going to be a big problem. So I'm sure there's at least some permafrost in Gilgit-Baltistan, and I'm sure it's also changing because the changes are very widespread. And this is going to cause problems in the immediate vicinity, for example, with roads, and also will affect changes in the discharge downstream because you have water stored in the permafrost as well.
Right. There's another question that, considering that mountain habitations are deeply affected by the cryosphere in so many different ways, the benefit of citizen science would be immense. So how much and in what different ways does AC Mode engage citizen science in its research in the Hindu Kush Himalaya region?
Yeah, one of the examples I showed was from Yala, that it's, we have the records from satellites, for example, we have the records from measurements, but also in some cases, the local communities have been there longer than we have the scientific records and can tell us, where did the glacier used to be, and how early did the snow used to melt, or how late, how much snow did you used to get, and people have stories, when I was a kid, it was, up to the door top, whatever, this kind of thing. So this is really useful. It's really extending your records in a lot of areas. In some parts of the world, people really like meteorological measurements. I know my dad used to have a little weather station and faithfully would tell us the temperature every morning and all the time. And these kinds of records are also very useful because it's quite hard and expensive setting up a weather station. But if you have, other people filling in these with their own records, this is a huge advantage. And weather especially is one thing that changes very much over quite small areas, especially precipitation. It's also, we have very few records of meteorology, as well as many other things at high elevation. So there's this huge data gap. And any records that we have from people, about snow records in the past or climate, that kind of thing is very useful. So these kinds of things, just observations. And we do now try and really make a point to talk to people as we're doing the work. Before, scientists would just breeze into an area and do the work and go and publish the papers. And apart from being quite rude, we can learn a lot from the local people. And we're also doing things which are a benefit to the local people. So if we tell them what we're doing, then they can give us the information we need. So again, in Humla, they were telling me when they had heavy snowfall that caused problems for years, and when they had avalanches in areas they hadn't seen before. And this really, is very incredibly useful for scientists.
Right. So I see that we're running out of time, and I'll just ask the last question here. We talked about glaciers melting away. Like, for example, the Yala Glacier, it's mentioned that it's decreasing really fast. So when a glacier melts, is it just lost forever? Is there any sort of information that we can salvage from that dying glacier to help other glaciated areas?
Okay, are you asking about, I'm just looking at the question here in my chat. So I think by information from a glacier, you're probably talking about ice core records. And this is something, when we're looking at the climate, as I said, we want to know how things were before. And actually ice core records can help us go back, not just tens of years, but hundreds and thousands of years. So several records being taken, for example, on the Dunda ice cap in China. And by analyzing the different ice layers, you can see how the climate was going back a few thousand years. With Yala, it was a very small glacier, even when people started measuring it in the 1980s. So it wouldn't be the best glacier to get those kinds of records. it's also relatively low. But basically, yeah, the information is lost, and this is a problem with Kilimanjaro. I think they've been trying to get some records from there because, you know, that's a very unique data set, apart from anything else, because it's telling you about what the climate's been like in that part of Africa where you don't have a lot of glaciers. So that's really useful. But once the ice is gone, it's, you know, even if the glacier somehow formed again, you're not going to get the record of past climate. And also another thing that when a glacier melts, you know, glaciers are sometimes several hundreds of meters thick. And if a glacier melts, then the area where the glacier was is now a few hundred meters lower because all the ice is gone. So it's going to be a lot harder for that glacier to reform. You know, before for example, the glacier I was working on in Norway was 600 meters thick. And the temperature was, you know, the temperature's enough that you always have a glacier there. If that all melts, the temperature is now going to be, say, 4 degrees warmer. So it's going to be a lot harder for a glacier to form again.
Right.
So once these things go, it's very hard for them to grow again. And if they do, you don't have that climate information that you had stored in them before.
Well, that is one other reason why we need to protect our glaciers, not just for our current needs, but also the history that they contain within themselves.
Yeah.
Well, thank you so very much, Dr. Jackson, for your amazing presentation, for answering all our questions. We're really happy to host you in this seminar. And I'm sure, just like me, not just a role model as a woman in science, early career researchers, but also the students who are listening us out there.
Okay, thank you. Thank you. It's been a pleasure. Thanks. And thank you for all your questions.